Okay, so absolute value equations and inequalities. So there are several different absolute value problems that you may encounter, but first let me talk about some general ideas with absolute value problems. Number one, the idea of splitting the equation or inequality, and we do this to account for both the positive and negative side of an absolute value converging to that positive value. Second idea is land and Gore, and so basically land represents a less than absolute value problem, and that means when we find our solutions, we want to make sure that both conditions are met. For Gore, which means greater than, for that particular absolute value problem, we're going to look at either solution and say that both are valid. So the third idea is negative multiplication / division. And basically, when you multiply or divide by a negative, you have to flip the sign of your inequality. So in this video, I'm going to cover 3 different absolute value problems that should cover basically anything that you may see. So number 1 is the idea of a single absolute value problem. Number 2 is a double or multiple absolute value problem. And number 3 is a complex absolute value problem, aka an absolute value in another absolute value. For all 3 different types of problems, I'm going to be looking at case studies or specific examples because it's much easier to look at examples and try to understand the abstract ideas behind a concept. So for single absolute value problems, we have our example, absolute value of x minus 9 minus 3x is greater than 4. So the first thing we want to do is isolate our absolute value, and this is just to make sure that the negative is being distributed appropriately when we look at the negative portion of that absolute value. So now that the absolute value is isolated, we can begin to look at the negative and positive sides of that absolute value. So the left is the positive and the right is the negative. And looking at the positive side, it's basically the same thing as the original equation, just without the absolute value signs. And so what we're left with is x minus 9 is greater than 4 plus 3x. Looking at the negative side on the right, there are 2 things happening. Number 1, the sign is being flipped. And number 2, the side without the absolute value is being multiplied by negative 1. So at this point, we have 2 different equations, and we solve for them separately, and we get 2 different solutions. X is less than negative 13 over 2 for the positive side, and x is less than 5/4 for the negative side. So this is where land and Gore come into play. So as you may recall, land is for less than absolute value problems, and Gore is for greater than absolute value problems. In this particular instance, we're looking at a Gore problem. And so what that means is we're considering both solutions as being valid. And so basically, we're trying to look at the solution that's more inclusive. And so in this particular instance, x less than 5/4 is more inclusive than x is less than negative 13 over 2. So x is less than 5/4 is our final answer. Moving on to double or multiple absolute value problems. Our example is 2 times absolute value 3x minus 2 minus absolute value 2x plus 4 is less than x minus 3. So the first thing we do is we solve for our zeros for each absolute value. We get x equals 2/3 and x equals negative 2. Second thing we do is we set these zeros to our intervals. And we get negative infinity to negative 2, negative 2 to 2/3, and 2/3 to infinity. The third thing we do is we test each absolute value in the given interval to see whether it's negative or positive. For the first interval, we get that both are negative. For the second interval, we get 3x minus 2 is negative, while 2x plus 4 is positive. For the third interval, we get that both are positive. So number 4 is taking those negative or positive values from the test intervals and applying them back into the original inequality to get 3 different inequalities to solve for. So solving for all of them, we get x is greater than 11/5 for the first interval, x is greater than 1/3 for the second interval, and x is less than 5/3 for the third interval. So step 5 is making sure that our solutions lie within their given intervals. Remember, we set intervals in step 2. So when we look at x is greater than 11/5, it does not lie within that negative infinity to negative 2 interval, so that's not one of our solutions. For x is greater than 1/3, it falls within the given interval, but only from 1/3 to 2/3. For x is less than 5/3, it falls within that 2/3 to infinity interval, but only on 2/3 to 5/3. So we have 1/3 to 2/3 and 2/3 to 5/3 as potential solutions. So in step 6, we combine them basically with our common 2/3, and we get 1/3 to 5/3 as our final answer. For complex absolute value problems, our example is 2 times absolute value of the absolute value of 5x plus 4 minus 7 is greater than 8. In step 1, we isolate the absolute value by dividing by 2, and we're left with absolute value of the absolute value of 5x plus 4 minus 7 is greater than 4. In step 2, we solve for the inner absolute value, and we get x equals negative 4/5. In step 3, we set that value to the intervals, and we get negative 4/5 to infinity as one interval, and negative infinity to negative 4/5 as another interval. In step 4, we take that inner absolute value and determine whether it's positive or negative on the given intervals. So 5x plus 4 is positive on the first interval and negative on the second interval. So here's where it starts to get a little bit tricky. So we do take that positive or negative value and substitute it back into the inequality. But the thing is, once we simplify it down, we're left with 2 more absolute value inequalities. So we have absolute value of 5x minus 3 is greater than 4 on the left, and absolute value of negative 5x minus 11 is greater than 4 on the right. And so what we do at this point is we actually solve for these 2 different absolute value inequalities independently. We only need to take into account the interval set in step 3 when we're considering the final solutions for each of the absolute value problems in step 5. So in step 6, we do what we always do when we're presented with a single absolute value problem. We set the absolute value to 0. And solving for each inequality, we have x equals 3/5 for the first and x equals negative 11/5 for the second. In step 7, we set those individual values as our intervals. So we have negative infinity to 3/5, 3/5 to infinity, negative infinity to negative 11/5, and negative 11/5 to infinity. In step 8, we determine whether these intervals are part of the subset intervals given in step 3. And so this is basically a worst case scenario. All 4 of these intervals fall within the subintervals. So in step 9, we evaluate the given inequality on that given interval, and so we get a negative, positive, positive, negative. So in step 10, we substitute those back in to the original inequalities for that subset, and what we end up with is negative 4/5 to negative 1/5, 7/5 to infinity, negative infinity to negative 3, and negative 7/5 to negative 4/5. So now we need to determine which solutions are legitimate. And so basically, we take each solution and make sure that they fall within the intervals on both the 3rd and 7th step. Luckily, all 4 of these solutions actually do fall within both the 7th and the 3rd interval. And so basically, what we're left with is negative infinity to negative 3, negative 7/5 to negative 1/5, and 7/5 to infinity. So basically, all 3 of those are our final answer. So that covers all 3 different types of problems. I've linked a worksheet below with the key. Feel free to check that out if you want some practice involving these different types of absolute value problems.